Yeah, I'm not going to faff around with long intros. Fairly technical talk, fairly practical talk. We're going to be talking about site speed, web performance, specifically one subset of web performance, which is optimizing largest contentful paint. Oh. One of 3 new web performance metrics coined by Google, part of the Core Web Vitals initiative. And yeah, I'm Harry. I'm an independent web performance consultant, which means I tend to work generally with fairly large clients, not exclusively, but it's generally people of this sort of size and scale who are going to benefit most from site speed, like optimization and improvements there. What I found very interesting, though, is since the advent of Google's Core Web Vitals, and sort of SEO being impacted by site speed or your ability to be fast, I've had a much greater, a much wider array of companies getting in touch, which is it's really interesting for me to work with just a greater variety of names, I guess. This talk is focusing very specifically on just one of the Core Web Vitals. It's LCP. That's absolutely, I did jinx that, didn't I?
You did. You said it's never let you down.
Until today. It would happen right here on home soil as well. So LCP, what is LCP? So like I said, it's one of 3 Core Web Vitals, 3 new performance metrics coined by Google, aiming to be a fairly user-centric performance metric. So if you've been doing web perf or even web development for any amount of time, you remember we had load times, then speed index. LCP is aimed or designed to be a much more user-centric measurement of how fast did the site appear, how fast did it load. The technical sort of description is pretty dry, pretty dull, pretty boring. But basically, it's when has the biggest piece of content loaded or been shown to a user. Biggest is it's a proxy for most important. The biggest bit of content isn't necessarily the most important piece of content, but it's hard for a machine to work out what the most important thing is. So taking the largest piece of content is a fairly reliable proxy for that. If we were to take the Storyblok stories on the road, sort of this homepage thing, it's actually this image element here. That would be the largest contentful paint element on this particular page. On my site, wearing the same shirt, you know, like that. That's not the same shirt. I have 5 of these. This is actually a background image. So it's an image element, but it's a background image. And there's a reason I'm going through different types of contentful paint element. Because if we take the meta homepage, the largest contentful paint element here is actually this H1. It's not this big image in the background. That's because this isn't actually an image, that's a video. And Google, when they defined the Core Web Vitals sort of metrics, they listed a series of elements that can or cannot or will not be counted as the largest contentful paint. Video elements currently, and we'll come back to that, video elements currently are not considered for your largest contentful paint. So that entire video gets ignored, and the largest single piece of content on this page is this H1. The reason I want to focus on LCP is because, in my opinion, it's the easiest of the Core Web Vitals to measure, to monitor, and debug. But interestingly, it's the one that the single one that we get most wrong, right? Only half of origins, half of websites in the Crux database actually manage to achieve a good LCP. I find this really interesting because it is definitely the easiest one to optimize. So this talk is going to be a really practical look at things we might be getting wrong, as well as opportunistic upgrades, things we can do better to get this good LCP. Which brings me on to what even is good, what constitutes a good LCP. Google have deemed 2.5 seconds the threshold for a good LCP. Getting the biggest piece of content rendered within 2.5 seconds is classed as good. This number wasn't simply plucked out of thin air. This number is based on some sort of fairly, I don't know, I guess psychology research, I suppose. 2.5 seconds is around the kind of time when the human brain will start to lose concentration, lose focus. But also, what they did is they decided that to confirm that a threshold is achievable, we require that at least 10% of origins currently meet the good threshold. So what they did is they don't want to create like an unachievable, like 0.5 second threshold. They took the web, ran some heuristics, and decided that, okay, currently, at the time of defining the metric, 10% of websites can achieve 2.5 seconds. If 10% of sites can do that, it's not too ambitious. This is very open to interpretation because this implies, or rather, I've inferred, this means that 2.5 seconds could change, right? Because currently we've seen 56% of sites are now achieving this metric. There is nothing to stop Google changing that 2.5 to 2.1, for example. There's no guarantee, well, I don't know if they're going to do that, but this is very open to interpretation, and it means that metric is fairly flexible, malleable, and may be updated, may be changed. Core Web Vitals has got people interested in site speed for an SEO kind of reason. I presume we're going to have some SEOs in the room. It's been great for business because people who weren't previously panicking about site speed have been getting in touch because now they are. But site speed is more than just SEO, right? Getting someone onto the site is like the first kind of battle, I guess. SEO is important. But site speed while they are on the site could be the difference between making a sale and not. And just to kind of this is a fascinating number. I worked with an e-commerce client last year in the Nordic sort of region, and we worked out if we could improve LCP by just half a second, they'd make an extra 11.5 million euro a year, just for a 500 millisecond improvement in LCP. I mean, you have to be working at a fairly big scale to be hitting these numbers, but this kind of goes to show the real importance of optimizing. Well, specifically in this case, it was LCP. So how do we get to good? How do we get to that 2.5 seconds? There's a bunch of ways of doing it, and the very first bit of advice I would give anyone who wants to improve their LCP is solve everything beforehand. LCP, large contentful paint, is what we call a milestone metric, and it is basically one of the last series of steps in the page load process. Basically, everything on screen here happens before your largest contentful paint. If you've got any delays in any of these steps, you're going to be on the back foot. So if you've got a really long time to first byte, you need to solve that. That's going to help you achieve that 2.5 second LTP. So anything on this slide that is currently problematic is going to be eating away into that 2.5 second budget. Interestingly, time to first byte and first contentful paint are web vitals. Google are tracking these, but they aren't core web vitals. So the core web vitals initiative is just the subset of 3 performance metrics that Google will use as a ranking factor. These 2, time first byte and first contentful paint, while they are web vitals, they aren't core web vitals. They aren't tracked as metrics that are going to affect your sort of your rankings, your SEO. So interestingly here, we can see this client of mine, they had a 2-second time to first byte. If you've got a 2.5 second budget for largest contentful paint, and you're wasting 2 seconds just on time to first byte, you're not leaving yourself much room to play with. What's interesting about this car crash of a website is when you look at these metrics, like I say, these are milestone timings. Time to first byte, we got the first bit of HTML onto the client. It took 2 seconds to get to that point. It took a further 1.6 seconds to display any of that content. Generally, you can proxy certain things from these numbers. If we've got a 1.6 second delta between first contentful and time to first byte, that's basically 1.6 seconds of render blocking assets. That's going to be render blocking JavaScript, it's going to be CSS, it's going to be stuff in your head tags. We then lost another, whatever that is, 1.8 seconds, getting to largest contentful paint. What's really frustrating about this site is the reason the delta between this and this is so big is a fully client-rendered JavaScript application. It was an empty HTML page, div ID equals app, and it still took 2 seconds to build. This site was a mess. But yeah, if you're losing 2 seconds of your 2.5 second budget to time to first byte, that's probably the first place you want to look. The next thing, and this kind of throws back to what I was saying earlier about an H1 or a video element or a background image, choose the best element. There is a small list of elements that can be considered for your largest contentful paint, and it matters which one you choose. It does make a difference. This is copied and pasted verbatim from the web.dev article on LCP. Your options are image elements. Image inside SVG, this is different. I mean, literally spelt different, but an image inside an SVG behaves differently to an image tag. A video element, if it has a poster image, so if your video doesn't have a poster image, it gets ignored. If the video has a poster attribute, then that image may be used. Background images or block level elements, such as text. What annoys me about this, and this is copied and pasted verbatim, what annoys me about this is Google don't actually tell you whether one of these is better or worse than the others. There are fundamental differences in how browsers treat each of these types of element that will affect your ability to be fast or slow. And they don't really tell you that you should avoid these and maybe prefer these. So that's what we're going to go through in this talk. We do love text-based LCPs. If your largest contentful paint element is a piece of text, you're bound to be fast. As long as you're treating your web fonts correctly, text-based LCPs are going to be some of the fastest. If we take my site, for example, on mobile, we'll see that the largest contentful paint element is this paragraph, and we got there in 844 milliseconds. As soon as we switch this to a desktop viewport and the LCP became an image rather than text, we'll see that it slipped way back to 1400. It's the exact same speed test, like it was a 3G fast, I think it was, exact same throttling. Simply by being a different screen size and like, having an image rather than text, we lost, what was that, 500 milliseconds, 560 milliseconds or so. So yeah, text-based LCPs are generally going to be way faster. However, it's not really good advice to go, oh, just get rid of your images, right? Just do that and you'll be fast. So in the event, oh yeah, and like I said, we need to make sure we are treating web fonts correctly. So make sure you're using the correct font display, swap, or ideally optional if you can get away with it. But yeah, more likely than not, we're going to be dealing with images. Image-based LCPs are statistically the most likely. At present, I think about 40% of web pages have an image-based, like an image tag LCP, which is the vast majority. Like most web pages, well, 40% isn't the majority of 100%, but what I mean is, given all of the options, images are way more common. I ran a little test, and the test was very, very simple, but I did something deliberately to try and trip the browser. I knew the browser, when I say the browser, we're talking Chrome. Well, it's the same in all browsers, actually, but these metrics only get captured in Chrome. I just ran a test with each of image in SVG, poster, and background image. But I also threw a render-blocking JavaScript file into the head of the page just to, one, stall the browser and like make it sort of like hang on like a render-blocking resource. I also wanted to introduce some network contention. What happens when two resources are in flight at the same time? One of them is render blocking, but one of them is the largest contentful paint element. Does the browser do anything smart, or do we do anything silly, or what happens when we've got that contention? And the results are pretty interesting. What we'll see is that image, okay, this is well overshot the 2.5 seconds, so don't look at the numbers as absolutes. I also forced that JavaScript file to delay for 1 second, just to exaggerate the tests, just to make things more visible. So don't look at these numbers in absolute terms, because none of them have hit 2.5 seconds. But just relative to each other, what I found very interesting was image in SVG was the fastest. Why was that? I was fascinated. Basically, less than 1% of sites actually use this. I don't know why Google have thought to track this or include this particular element. But this was a weird one. This came back a bit unusual. When I visualized the data, what I found was that image in SVG was actually captured wrong. Image in SVG was actually quite slow. If you want to game the system for the next couple of weeks, go and refactor all your sites to use image in SVG, because it completely misses that element. Even though it's in the documentation that image in SVG is a candidate, it actually took the paragraph. So what was quite interesting there is that Google have sort of written this documentation, written this spec. Chrome doesn't actually adhere to their own spec. So if you want to game the system for a few weeks until it's fixed, go and put all your images into SVGs. When adjusted for what really happened, we found that the numbers were a little more different. Image in SVG actually became the second slowest element. Now, there's interesting reasons for this, and you can visualize it better in a waterfall chart. If we look at the image at the top, what we'll see is that even though the image was defined second in the HTML, it was discovered first. So the image is the big purple thing, and this one here, this like pale orange thing, that's the JavaScript. Even though the image was defined second, it was discovered first, and it was requested and downloaded in parallel with the JavaScript. Image in SVG, different behavior. The image was discovered second, and it wasn't discovered until after the JavaScript had finished. So we completely lost parallelization, and this is why it's significantly slow. And we'll see that poster and image behave the same, and SVG and background image also behave the same. I was expecting background image to behave like this, because background images, the way CSS works and the way browsers have to work, background image is always going to be slow. I was expecting this. What I wasn't expecting was image in SVG. So what we'll look at is why this happens and what we can do to get around it. Yeah, so those kind of patterns emerged. Image is good. Image is really good. Image is fast, and we can make it faster as well. But image is good because it's just a really nice, simple bit of HTML. Browsers love HTML. Giving this to a browser is going to be fast. What we see here, like I say, is the image is downloaded in parallel with the JavaScript. It's actually discovered before the JavaScript as well, which is kind of interesting. That's actually a Chrome internal thing that's a bit too esoteric to get into, but the image is requested before the JavaScript, despite the JavaScript being sort of referenced first. The reason this happens is because of something called the preload scanner. Start a timer. See what it's up to. Right, the preload scanner, in every single modern browser, there's a beautiful, this is a very elegant bit of design. There's a thing called the preload scanner. Loading web pages historically was a very slow process because the same parser that was sort of parsing the HTML was responsible for discovering resources, downloading resources, then applying those resources to the page. When we talk about the parser, we're generally talking about the main thread. When there's only one thread to do all that work, things get slow. So in IE8 of all things, would you believe it, Microsoft invented the preload scanner. Well, actually, no, because it was Microsoft, it needed to sound enterprisey, because someone needed to get paid for this. They called it the speculative pre-parser. Everyone else just calls it the preload scanner. It exists in every browser, and it's like I say, it's a very, very elegant mechanism for discovering resources ahead of time. It made the web a lot faster. I can't find the research paper or like the write-up. I can't find it anymore, but you just have to trust me on this. It made the web about 19% faster for free. Developers don't have to do anything to access the preload scanner. It's already there. The thing developers do end up doing quite a lot of the time is inadvertently hiding things from the preload scanner. That's what's happened with the background image, and it turns out that's what happened with image in SVG. So in the olden days, when one parser has to discover the files and download them, everything was sequential. Downloading 3 JavaScript files in an image used to look like this, really, really slow. As soon as the preload scanner was invented, downloads became asynchronous, while execution remained, for the most part, synchronous. Literally for free, we went from the top to the bottom overnight. And this is in every single modern browser. You're currently experiencing and benefiting from this. Image in SVG is bad because it turns out images in SVG are hidden from the preload scanner. The preload scanner can't find images that are referenced inside SVG. I don't know for definite if this is the case, but I think simply it's because the preload scanner is designed to parse HTML, and SVG is XML in HTML. So my theory is because this is SVG, XML embedded in HTML, the preload scanner simply isn't built to parse XML. It's just for HTML. That's my theory. Because that's hidden from the preload scanner, what that means is the browser can't even find this image href until it's finished running that JavaScript. That's why the waterfall looked like this. So image in SVG, none of you are using it anyway, but it is slow. I'm genuinely baffled as to why this was included because if you look at the statistics, it is less than 1% of web pages, not websites, less than 1% of web pages actually have their largest bit of content in an SVG. It's an odd thing for Google to have included in the Core Web Vitals, but that's the case. So yeah, images hidden from the preload scanner, it makes it inherently slow. Like I say, unlikely you're going to use it, but I wouldn't recommend it, even for gaming the system, which may be fixed. I need to double check the bug. Poster is really good. This is a nice surprise. When the poster attribute and the video element and its poster attribute were designed, the poster attribute is surfaced to the preload scanner, and it looks like this. It's just an attribute on your video tag, points to whatever the placeholder image will be. Some interesting stuff going on with video, and I'll come back to it in a couple of slides, but this behaves exactly the same as image. It's really, really good. You can't make poster images much faster. We can make image tags faster, but that's about as fast as a poster image will ever get. It's downloaded in parallel, it's available to the preload scanner, it's generally well built. So it's a pleasant surprise, it behaves like an image. What is interesting, if you do have a video, make sure you are using a poster element. If you're not, you may find that in the next few months, you're going to get your sort of like fingers burnt, because Google or Chrome are considering taking the first frame of a video as their as their LTP element. Currently, a video element with a poster image is not counted. The first frame of a video, when painted, should be considered as the LTP candidate. That's from an open bug against Chromium. It has been requested. Basically, someone wants the first frame of a video to be included in the sort of list of candidates for an LTP. That someone, fucking YouTube. It's such a... I really don't like the stronghold Google has on the web. And basically what's happened is when YouTube were doing optimisations, they wanted to make YouTube faster. One thing they realized, if someone links you to a YouTube video, it's going to start auto-playing. And what they realized is that if an auto-playing video starts with a poster image, because you can select your poster image, right? It doesn't have to be the first frame of the video. You can select any poster image. They found the user experience was really bad if you see a poster image and then the video starts auto-playing. So what YouTube does is it actually just shows you blank screen. It shows you nothing at all if the video autoplays. So it goes from blank, like black, to playing the video. So what they've decided was, well, actually, we don't want poster images on YouTube. What we want is the first frame to be counted. So now YouTube have gone to the other team within Google and said, can you start including the first frame of a video? That is super annoying, because if you are using video, currently it won't get counted. In a couple of months, there's a high chance it will start counting the first frame of a video. You're really going to struggle to get a good LTP with videos. So that's why I sort of said it's really important, if you are using video, use a poster image, because that's going to be way, way faster than your first frame. Thanks, YouTube. Background image is bad. Background image behaves the same way as image in SVG, and that's, again, because it's hidden from the preload scanner. It's hidden from the preload scanner for subtly different reasons, but the net outcome is still the same. What I did is, in my demo, I just put an inline style attribute in the HTML. Obviously, if I'd have made an external CSS file, that would have been slower. So I just did an inline style, and the waterfall came out looking exactly the same as image in SVG. The reason for this is actually, again, a very elegant bit of browser design. It's a conservative bit of design to stop wasted downloads, but the outcome is it makes things slower. So it saves data, but it takes more time. Background image is bad because it's also hidden from the preload scanner. Background images and web fonts are what we call late discovered resources. If you imagine you link to a Google Fonts CSS file, and in there are 10 different font face rules. The browser will only download the fonts the page actually needs. Right? It's conservative, it's sensible. So it can read 10 font face declarations. It will only download the fonts the current page actually needs. Same with background images. That's why you can have a CSS file with 100 background images in there. The browser only ever downloads the image the page, or images, the page currently needs. So it's conservative to save bytes. The problem is, the browser doesn't know it needs that image until it's ready to paint that specific DOM node. Something really interesting that a lot of people, a lot of my clients don't realize about CSS is CSS doesn't download your background images. Even though it says background image brackets URL whatever, your CSS is not responsible for requesting those images. It's actually the DOM node in the page that needs it. So what happens is the browser takes the HTML, builds the DOM, takes the CSS, builds the CSS on, puts those together into the render tree. HTML is parsed line by line. So if you've got a div that's got a background image applied to it, the browser doesn't know it needs that background image until it gets to the opening div tag, sees whatever ID or class is on there, and it's like, oh shit, I need an image. When people try and optimize things like web font delivery and optimize like background image delivery, the first thing they look at is CSS. The bottleneck is always the HTML. The browser doesn't request that font or that image until the DOM node that requires it is encountered by the parser. So general tip there, if you're trying to make anything to do with CSS faster, basically background images or fonts, optimize your HTML, not your CSS. That's a way more succinct way of saying what I just said. But yeah, it's not the CSS that requests the image, it's the DOM node that needs it. So takeaways there, not all candidates are born equal. Some are inherently faster than others. Image is statistically the most likely to be used, and it's also pretty fast. So what I want to show you next throughout the talk, well, not next, but later in the talk, ways we can push image even faster. Image is nice because it's got some opportunistic upgrades that other things don't have, that you can't do with post, you can't do with background image. Common mistakes. Some things that developers frequently get wrong. This next one just, it used to really upset me, now it just infuriates me. Don't lazy load your LTP. You see this all the time. Oh yeah, lazy loading makes sites faster. Well yeah, by making your images slower. And if you're trying to optimize for largest contentful paint, do not lazy load your main image. Staggeringly, what's the numbers? About 10% of web pages use native lazy loading on their LTP. That's developers making their site slower. It's approximated a further sort of 5 to 6% are using a JavaScript-based lazy loading library, which makes things even slower. So if you're optimizing for LTP, make sure you're not lazy loading that image. The biggest contributor to this was, I think it was WP Rocket or some WordPress plugin. It was like, hey, do you want to make your site faster? Click this button. And it just lazy loaded every image on that site, including the above the fold important images. I had this sort of like battle, it was a bit of an argument, to be honest, with a client recently. And the way their site was set up, it was a bit clunky, a bit old, and basically they had two options: lazy load everything or lazy load nothing. And my advice to them was just lazy load nothing. If you've got a plugin that will lazy load your LTP I'd turn lazy loading off completely. Just do without lazy loading, period. What you don't ever want to do is sacrifice LCP for like below the fold images. So if you have to choose one or the other, choose lazy loading, nothing. Yeah, the syntax for this, loading equals lazy, dead simple, nice and declarative. But what I find quite interesting, a lot of well-meaning developers have asked me this. Can't we just add loading equals lazy to every image? Because the browser knows what to do. The browser will only lazy load an image if it's out of the viewport, right? The browser's smart. It will work out how close the image is to being scrolled into viewport. It will take things about the network data, like how fast or slow is the connection. So a lot of developers have asked me, like, well, can't we just put loading equals lazy on the image, and the browser just intelligently decides what to do? The problem with that is, well, actually, there's two problems with this. By the time the browser knows it needs the image, that's already way too late. The browser needs to know that it needs the image before it's ready to paint the image. The second thing, and this is very, very elegant, loading equals lazy hides the image from the preload scanner. This is a smart, I think, very elegant bit of design by the Chromium engineers. What they decided is, if an image is lazy loaded, hide it from the preload scanner. Wait until the parser reaches that line of HTML before dispatching the request. What that means is the moment we put loading equals lazy on that image tag, we go from the top to the bottom. This is now behaving just as bad as image in SVG or background image. This is why I advise people, don't ever lazy load your above the fold content because it's going to be dramatically slower. Clients seem to really love this next slide. It's like, I'm not a very smart guy. I really like sort of low fidelity solutions to problems. I just put that in a custom user style sheet in Chrome, throw a red border around any lazy loaded image, and I'll just click around my client's websites looking for anything above the fold that turns red. Oh my God, how did you work this out? I was like, it's this. So it worked out, yeah, The Economist, they were lazy loading some stuff above the fold, and that was just really obvious candidates for don't do that anymore. Don't build your LCP in JavaScript. JavaScript's probably the fastest way to build yourself a slow website. We don't like JavaScript. We don't like JavaScript at all. I was working with iPlayer about a year ago now, and they did a really baffling decision. iPlayer is a fully, well, 95% server-rendered React application. So it's mostly built on the server, except for some reason, the actual video player itself, not the interactivity of the video player, but actually just the holding splash sort of hero image, was built on the client. For some reason, they built not the actual video player, that does need to be JavaScript, but the actual just frame of the video is all done via app.js on the client. What this meant was we had to wait until app.js was downloaded, which took to about 7.5 seconds. Then that had to run and hydrate the HTML or the virtual DOM. And then it went off and then dispatched a request for the image. It took the developers about 90 minutes to do it. I said, look, can you just make sure you server render this component as well? And within 90 minutes, they'd gone from that being the 43rd request, dispatched around 7.5 seconds, to being the 17th request, still not great, dispatched around 4.5 seconds. Still a lot of progress to be made here. That was just one subtle optimization. But building the LCP in JavaScript, whether that's a client-rendered app or even if that's just using lazy loading in JavaScript, it's the fastest way to be slow. Other optimizations we had was, yeah, don't host this on a different origin, but that certainly at the BBC scale, it's a lot easier said than done. You can hopefully see on this graph the day we made that change. It's pretty good. Made a pretty big dent in things. The engineering effort was actually quite small as well. iPlayer aren't too bothered about SEO. They're not bothered about optimizing for like the rankings. But anything to improve the user experience was definitely just up for discussion, up for implementation. What was that, like a 43% improvement? It took about 90 minutes to do, so it was well worth it. Coming back to that hosting offsite, don't host your images offsite. Your LCP candidates should be hosted on the same origin wherever possible. If you're using someone like Shopify, you're probably going to have to link out to cdn.shopify.com. That's a real shame. You can't really do much about that. Hosting images offsite, or your important above the fold images offsite, is going to slow you down. The best example I have of this was myself. I accidentally, a few months ago, nudged my big LCP image onto Cloudinary. Cloudinary is wonderful, right? Auto-magically optimizes my images on the fly, because I can't be bothered doing it, because I'm a developer and we're lazy. But I accidentally nudged my LCP onto Cloudinary. You can see the days that regression was live. I'd gone well over budget, so I was at 3.5 second LCP rather than 2.5. I'd gone from 2.1-ish to 3.5, so I was gone way over budget. Basically, even though the image was 1.5 times smaller on Cloudinary had optimized it to be 1.5 times smaller in file size, actually took 2.6 times longer to display it. So it's not worth it. And do you know what I actually did? Because I'm really lazy. I just did right-click, save as, save the optimized Cloudinary image, and moved it onto my own origin, best of both worlds. Don't usurp your LCP. I hate this slide. I've tried, the word usurp's pretty archaic. What I mean by this is don't undermine or overthrow, or one of the synonyms for usurp is overrule or dethrone. But don't shoot yourself in the foot. This one is heartbreaking. This one happens all the time. I want to show you a slide now. Have a drink of water, and I want you to try and work out what's happened. On day one, I mean, this is a really slow connection, and this is before we work together, so this is why everything's slow. Basically, on day one, LCP was 8.1 seconds. On day two, it went up to 12.5 seconds. It got 54% worse. Can anybody work out what's happened? Why we got this regression? Feel like you were maybe close down the front? Someone noticed something? Heard some whispering?
I was suggesting it could be like a funnel, but slowing it down because it's text overlapping.
Sort of. So basically, the text overlapping is part of it. In the middle, we've got a visual diff, right? Basically, what had happened, and I can't remember which e-commerce platform they used, but this is pretty smart. On day one, the LCP candidate was the H1. It was 46,000 square pixels. Mental just how many pixels are on a screen. 46,000. But they sold the last mountain bike. They sold the last Cannondale mountain bike. There's only one left, look, and they sold it. Without redirecting the user, the CMS automatically was like, well, we can't sell you a Cannondale one, we'll show you all mountain bikes. This one's only 33,000 square pixels. The late loaded cookie banner remained the same size, 44.5 from day one to day two. But because this is late loaded, the JavaScript fires later, this appears and it stole the LCP away from in the HTML server rendered H1 to the JavaScript generated paragraph down here. The reason this is so heartbreaking is because on localhost, you don't have your cookie banner. Or if you do, you've accepted cookies anyway, right? You don't see this most of the time. Developers miss this. And usually it's not a developer who implemented this. It's going to be some annoying pop-up that asks you to sign up for the newsletter when you've been on the site for 3 seconds. Developers don't normally see this on localhost, so developers think they've built this. Whereas marketing and GDPR, they built this. And it wasn't, no developer caught this. I didn't catch this. Luckily, SpeedCurve, the monitoring that I use, SpeedCurve caught this. I find this really upsetting. Like, cookie banners constantly steal LCP away from first-party content. Optimizations here are load your cookie or consent banner as fast as possible. Make sure your cookie or consent banner is smaller than your first-party content, or, and this is pretty sly, Chrome stops looking for LCP events as soon as the user interacts with anything at all. So what you could do is wait until a user scrolls just 1 pixel. And if they scroll just 1 pixel, then give them the cookie banner. That will optimize LCP from a numbers perspective, but it might not be the best user experience. But the takeaway there is Chrome stops measuring LCP events after any user interaction. That's usually because someone might scroll down the page and a big image comes into view. It's going to be really cruel if they're, oh, your LCP was actually 5 minutes, because it took a user that long to get to the bottom of the article. Right, what's this? Oh yeah, there we go. That's just what I said. OK, we've looked at things we get wrong, or things that can trip us up. Next, I want to just look at some sort of overachievey bits, some stretch goals, things we can do to get a bit faster and sort of get ahead of the curve. First thing you may have heard of, and do you know what, by now you probably have heard of, these have been in browsers for a long time, it's resource hints. Resource hints are to be used sparingly, I would say, and the resource hint we're going to look at is actually preload. Anyone used preload before? A bunch of us probably. Yeah, that's great. Honestly, use these sparingly. They can be a bit of an anti-pattern. Preload is great for any LCP that is a background image. Generally speaking, a good rule of thumb is that if your LCP is a background image, you would use preload. Because, and there's a clue in the name, preload reintroduces things to the preload scanner. Any late discovered resource, web fonts or background images, is a good candidate for preload because you can tell the browser, you don't know it, but you're going to request this background image kind of soon. Like, do it now, ahead of time. Use these sparingly. There's a bug in Chrome that is still kind of pervasive and kind of persistent. Preload can make your website slower if you're not careful. But if you've got a background image-based LTP, using preload is probably the best way to optimize it. On my site, because my site is a background image LTP, you will find, and there's some really fascinating stuff to unpack here. I have to check my notes so I just make sure I say everything correctly. But in Chrome, or any Chromium-based browser, there's a two-phase loading strategy. It's called type mode and regular, I think. Basically, you can spot from a waterfall chart, you can spot where your head tags are. If you look at the top, I've only got one style sheet in my head tag, so if you look at the top screenshot, what you'll see is I've got the HTML, one CSS file on its own, kind of orphaned, nothing in parallel, then everything else. The everything else is the start of your body tags. And every Chromium-based browser has this two-phase loading strategy. What you'll see is the image here is the fourth request, this masthead.jpg, fourth request, requested definitely from the body after the CSS, and it took 932 milliseconds. As soon as I put a preload in the head tags, it went from the fourth request to the third, so not really much difference. But you can see it's been requested alongside that CSS, so it's now being requested from the head tags. Here's the interesting bit. 932 milliseconds to download that image. The exact same image, no difference in file size, took less than half the time, 445 milliseconds. That's because if you look at this top one, the browser's downloading a bit of image here, downloading a bit of HTML there, some JavaScript here, some image there. Bandwidth is finite, and it gets diluted and distributed. If that image is being downloaded alongside several other resources, which it was here, overall it's going to take longer. Because it was requested out of the head tags, the browser dedicated or donated 100% of bandwidth for that image. You'll see here, that big non-stop continuous dark purple is just pure download time. That is the browser sending bytes. I genuinely think, like from two little screenshots, there's a lot to unpack there. One, Chrome has a two-phase loading strategy. Your head tags, you can usually visualize in a waterfall quite easily. Your body tags come second. But also, Chrome will donate bandwidth to more important resources. And as soon as we preloaded that image, we signaled it was more important. It took less than half the amount of time to download the exact same amount of bytes. Yeah, I mentioned this briefly. Beware Google Chrome. There is a bug. Please, before you go and implement preload, if you've never used preload before, please just go and read that article first. There are some bugs in Chrome. Preload can make your website slower. Woo. Priority hints. Anybody used priority hints yet? Not many of us. This is wild. This is probably my favorite thing in the entire talk, because it's just really, it's a lot of bang for your buck. Priority hints look as simple as this. Fetch priority equals high. You could also use auto, which is the same as doing nothing at all, so it's kind of redundant. Or you could use fetch priority equals low. This is just a game changer. This is only available in Chrome at the moment, but it's a really, really powerful and very simple tool. Basically, preload is good for background images, and you would put a preload in the head tags. Generally speaking, fetch priority you would use on an image tag in the body, generally speaking. If your LCP is an image, you probably want to just, like, as soon as you get to the office tomorrow, go and stick fetch priority equals high on there. Basically, yeah, it's really, really powerful. It allows us to control priorities. We need a quick intro to what priorities are. All browsers, this is specifically Chrome, but all browsers implement a prioritization mechanism. And it's basically when the browser first loads an HTML page, it needs to make a bit of a shopping list. And some things are going to be more important to the page than others. CSS, vital to the page. You can't render well, actually, HTML, the main resource, very important. You can't render a page without the page. CSS, that's render blocking, highest priority, blah, 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 blah. But images all start life as low priority. If the browser works out the images in the viewport, and again, by that point, it's too late, because the browser only knows the images in the viewport when it's about to display it in the viewport. The browser can change the priority to high. It sends another header up the wire, says, right, this is now a high priority image. It's not a header, but sends a bit of data back to the server and changes it. So you can see image initial priority was low, requested priority was high. The browser decided, oh shit, this image is actually in the viewport, way more important than I realized, and it will send a second requested priority equals high. I'm going to show you a video in a minute, well, not in a minute, in about a few seconds. Keep an eye on the red circle. This is The Economist, and this LTP image is about to appear. If you look at that red circle, it took the browser quite a while to realize that image was actually quite important to the page. It was like, okay, we've got an image, I'll request it. Then, after a while, it realized, oh, it's in the viewport, that was important. If we look, what the browser did here was, queued that image for 2.16 seconds. Basically, what the browser did is at 800 milliseconds in, the browser knew an image was needed. It wasn't until 2.16 seconds later, the browser realized, oh, I'd better request this. If you've got a 2.5 second budget for LTP, what you don't want is the browser twiddling its thumbs for 2.16 of those seconds. I'm going to show you a screen. Oh, yeah, and that led to an LTP event at 14 seconds, which is completely inappropriate. What I did, pro tip, anyone who is a freelancer or independent, never tell your clients what you did for them. Tell your clients the results of what you did for them, because there's no way I can submit an invoice for that. I stuck fetch priority high on this image, and things just got well, I was going to say immeasurably better, but it's definitely measurable. I'm about to show you. Watch that red circle again. Immediately went to high priority. If we pull those numbers out, what we'll see is that it spent 0.85 milliseconds queuing. From 2.16 seconds to 0. Also, never tell your clients absolute numbers, because what I told my client was I didn't tell them it's 2 seconds faster. I said it's over 2,000 times faster. Less than 1 millisecond, as opposed to 2,160 milliseconds, so 2,000 times faster. And you see that the LTP event, exact same page, just for those few bytes of HTML, a 5-second LTP. Again, not good enough, nowhere near good enough, but for the sake of a few keystrokes, getting back nearly 9 seconds of LTP is wild. Just to pull out those highlight numbers there, basically almost a 100% improvement in queuing and a nearly 9-second improvement in LTP. So fetch priority is really, really powerful. My God, this is a long talk. We're nearly there, don't worry. This is very, very new. Image decoding is a very new sort of API we've been given. It's also the least utilized and probably, certainly in my opinion, the least well explained. It's very obscure. The closest you'll get to an explanation is from the spec, and it simply says, image decoding is said to be synchronous if it prevents presentation of other content until it's finished. When you read this, certainly when I read this, I see the word prevent, and I'm like, well, this sounds like a bad idea. I don't want to prevent anything. But if you actually consider what this is saying is, if you make image decoding synchronous, the browser will not display surrounding content until it's finished decoding the image. If you want to display an image very quickly, this is probably the right thing to do. So I ran a little test, a little experiment. What you can do is you can tell the browser how to decode images. Does it do it asynchronously or synchronously? So we've got decoding equals sync, async, or auto. Again, auto is redundant because it just means do whatever you were going to do in the first place. Dead simple. Decoding equals async is going to be the one that allows the browser to render content around the image. This is basically the one that I wouldn't recommend for your LTP. But what I did is I ran 2 tests. What happens if I explicitly tell the browser, decode this image asynchronously? Feel free to render an H1 or a paragraph or a list in and amongst decoding this image. This next screenshot is really ugly and it's probably a bit too small, so I do apologize. But what I want to show you here is a few standout sort of things. I ran a little performance profile. What I did is, this is a really unoptimized image. This image is like a 12 meg JPEG, again, just to kind of highlight and exaggerate the tests. First thing we see is we've got a frame here presented around DOM content loaded in which we can just see the image starting to decode. We've got a thin sliver of image. Then, a little while later, we've got a second frame presented. The image is no more decoded. It's not changed at all. The browser's rendered a new frame, but nothing's actually changed above the fold. What the browser was actually doing is it was laying out 1,000 paragraphs. What I've got is 1,000 paragraph elements underneath this image. Third frame is the fully decoded image. And you can see that coincides exactly with the LCP event. And what we'll find is that because we told the browser you are allowed to decode this image asynchronously, it snuck in a layout task here. So what it is, it started to decode the image. You've got a little image decode task there, began decoding the image. Then it did a recalc style and layout for those 1,000 paragraphs that were off screen anyway, no use to anyone. And then finally, moved back to the image. That led to an overall elapsed time of, you've got no chance of seeing that, 700 milliseconds. From the first frame to the last frame, 700 milliseconds of time had elapsed. Again, if you've got a 2,500 millisecond budget, losing 700 of it just to decoding an image is not very good. So I changed async to sync, basically telling the browser, once you've started decoding this image, you can't do anything else until you finish decoding it. What we got here is, again, the first frame, thin sliver of image decoded. Second frame is fully decoded. There is no third frame. What we'll see here is, I always feel bad because this looks like Pepe the Frog, and that's not good. What we'll see here is that we've got an image decode, nothing else in between. The browser didn't not waste, but the browser didn't give any CPU cycles to painting off-screen text. What this led to is a 323 millisecond elapsed time. The key thing here is the image wasn't decoded any faster. This browser had to decode the same amount of megabytes of image, but it just didn't do anything else in between. So it still took the same amount of time. We just didn't do anything else instead. So it meant the overall elapsed time was twice as fast. A pattern that I'm beginning to slowly recommend to clients, and again, please test everything. Every time you put fetch priority high on an image, also put decoding equals sync. You should never see this more than once on any given page if you put fetch priority high on everything. If you make everything high priority, nothing's high priority, right? So you need to use it sparingly. That's a pattern I'm starting to recommend. The flip side, the reverse of which, is anytime you put loading equals lazy on an image, maybe put decoding equals async on there as well. Hey, Zeus. Right. Yeah, that was a lot. I'm sorry, that was a lot. LTP is the final metric. Solve everything beforehand. If you've got time to first byte issues, solve them. Choose the best candidate. Text is best, but not very practical. Image is the second best, because we can complement that with things like decoding, fetch priority, etc. Expose the LTP candidate early. We love HTML. Don't build your LTP in JavaScript at all. Don't work against the grain. Don't make silly mistakes. Step in and help the browser. When you know more than the browser does, step in and help. That's things like using fetch priority, using decoding. And as ever, test everything, because especially in the case of preload, there are instances in which it can make your website slower. So everything I've just told you generally works, but please test everything before you deploy it. And with that, I want to say thank you very much for your time. Thank you for your patience, because that was a longer talk than I was expecting. Thank you very much.